Welcome to an Achieving Science video. This video is going to look at half-life. Before we begin then, let's just remember about radioactive decay. Radioactive decay is where unstable nucleus decays, i.e. breaks down and emits radiation randomly. This means that as more unstable nuclei decay, there are actually less nuclei decay, and we say that there is less radiation. Remember that this is random. Therefore, this is not affected by temperature or pressure. Now let's move on to half-life. We need to define it. This is the time taken for the count rate to halve, or alternatively, the time taken for the number of nuclei of an isotope in a sample to halve. You can use either of these as your definition. Now this can take hours, weeks, years, or even millions of years, but it will never reach zero. Now this can more easily be shown via a graph. So here we have a graph that shows half-life, where on the x-axis we have time. On the y-axis we have the activity of the sample. This could be replaced by the count rate. Now the graph shows that as the time period increases, the activity of the source decreases. So where is half-life used? Well, the uses of half-life include carbon dating using radioactivity. So if you know the half-life of a particular isotope, you can look at how much of it is left. Now let's look at a question. If a substance has an initial count rate of 5,000, how many half-lives does it need to go through in order to have a count rate of 625? Write out what you know from the question. So it says initially you start at 5,000. After a first half-life then, where it halves, it will become 2,500. After a second half-life, it will become 1,250. After a third half-life, it will become 625. So therefore, this is an example of 3 half-lives.